how do we find the derivative of 1 plus x to the power of x? In this example, we have our independent variable x in both the base and the exponent. So this is a classic case where you want to use logarithmic differentiation. I'll leave a link in the description to my lesson introducing logarithmic differentiation, but you may be able to understand it here even if you're seeing it for the first time. We'll say that y equals 1 plus x to the x. So that's just assigning a name to the function that we're trying to differentiate. Then, to get this troublesome variable x out of the power, we're going to take the log on the left side and the log on the right side. The log of y is just log y, and of course the log of 1 plus x to the x is log 1 plus x to the x. In theory, you could use any logarithm you like, but generally we use the natural log, and for convenience refer to it simply as the log. Now on the left we still have log y, but on the right we can apply our log rules. With an exponent applied to the input of the log function, we can take that exponent out of the log function as a factor. So this is equal to x times log of 1 plus x. Now we can take the derivative of both sides, and what we'll have to do is use implicit differentiation for ln y on the left, and on the right we'll just have to use the product rule. Then we'll go ahead and solve for dy dx. So we're taking the derivative on the left with respect to x, and taking the derivative on the right with respect to x. The derivative of the natural log of y with respect to x is 1 over y, that's 1 over the input, but then y is itself a function of x, so by the chain rule, we have to multiply by dy dx. Again, this is implicit differentiation. I'll leave a link in the description to my lesson introducing that if it's unfamiliar to you, but it's really just a chain rule, except it looks a little scarier. On the right, the derivative of x ln of 1 plus x is found with the product rule, f prime g plus g prime f. F prime, the derivative of the first function, is just 1. So f prime g is just 1 times the natural log of 1 plus x. Then we have g prime f. G prime, the derivative of the second function, is just 1 over 1 plus x. F is the first function, so g prime f is 1 over 1 plus x times x, so x over 1 plus x. Now all we have to do is solve this equation for dy dx, which we accomplish by multiplying through by y. So on the right, this whole thing gets multiplied by y. That way we can cancel out the y on the left. But remember, y is something we know very well. Y is 1 plus x to the x, and certainly we want to express our derivative in terms of x. So rather than writing multiply by y, we write multiply by 1 plus x to the x, and this whole thing you see is in brackets. You may be content to leave your answer like that, but we could also distribute and have 1 plus x to the x times ln of 1 plus x, and then when we multiply 1 plus x to the x over here, there's actually a 1 plus x in the denominator to cancel out one of the factors of 1 plus x in the numerator. And so that would simplify to just x times 1 plus x to the x minus 1. So that's your answer, or that's your answer. They're both pretty ugly, but you may prefer one to the other. Let me know in the comments if you have any questions, and be sure to check out my Calculus 1 course and Calculus 1 exercises playlists in the description for more. Thanks for watching.
Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about. Stressed out, honey, I've been stressed out lately. Don't know what's what, don't know what I'm stressed about. Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed